So we'll just like summarize the slack and shadow price. So slack is a variable where we have surplus. Okay, we have surplus things. So if you see here, there are like two lines here, two constraint lines which are surplusly available, right? The optimum point is B, right? So in optimum point B, full of build time and full of sales units of Y, it's like fully they are used. Okay, but if you take test time is like surplusly available and program time is surplusly available. So slack will always be there. Slack is what is in excess. Okay, what is still surplusly available. Okay, so first we'll try to find out slack. So first we'll get slack here. If available used is positive, it indicates slack. Applying x and y in constraints. Okay, so we got the optimal point that 20,000 units of x has to be produced and 66,000 of y has to be produced. We got that from the optimum point. That optimum point is nothing but this B point. Okay, this B point. So let's put 20,000 in, okay, in x and 66,000 in y. Okay, if you put that, see, 20,000 units of x has to be produced. Okay, and each product has to be produced at 10 minutes and 60 hours is there. Okay, that is 60 minutes in a hour. So we are converting all this in terms of hours and checking it out. Okay, so here 66,000 into 4, okay, units into 4 hours of test time is required for y. Okay, so we totally require 7,733 hours. Okay, what is maximum available? So maximum available they have given it. So they have given it as 12,000 hours. See, it's up to you to find out either in minutes or hours. Okay, however you do it, it will give you the same answer. So test hours is 12,000 hours which is available, right? So available is 12,000 hours, but used is only 7,733 hours. So still we have surplus. Okay, so that is called as slack. So we'll apply it to the other one. Other one is program time. So program time, if we apply 20,000 of x multiplied 16 minutes divided by 60 minutes in plus 66,000 units of y into 14 minutes per y divided by 60 minutes. Okay, we get 20,733 hours. So how much is available for program? So available is, I think, what was the thing we are looking at? Program time. Okay, so program time, if you look, available is 28,000 hours. Okay, 28,000 hours. So look here, we still have 7,200 hours surplus available. Okay, the slack values for tested time and program time mean that there are surplus hours are available in each. Okay, so when there is slack, you don't need additional amount of that constraints. You don't need to have additional. Already there is so much additional. Why do you need more additional? So we will now see the concept of shadow price. Okay, we will see shadow price. Okay, see, shadow price refers to, shadow price will be only available on the lines which are the optimum point. So optimum point lines are two lines, maximum sales of y and build time. These are the shadow price lines. Okay, so they will be like fully used. Let's check that. Okay, as there is slack in time and the program time, okay, test time and program, there is no need for that resource. Okay, we shall test for build time. For that alone, we'll just test and we'll see. So this is the equation. We'll substitute the equation. Okay, we'll substitute the equation and see. See, when we solve it, this number actually comes to 1.8 million. Okay, 1.8 million minutes it comes to. That means there is no slack at all. See, you can find out this in either in hours or minutes. That doesn't matter. But however you find it out, there is no surplus at all. It is fully used. Okay. So what we'll do is we'll assume that shadow price refers to the contribution that you are earning by increasing one unit availability of the constraint. Okay, so here the availability constraint is the build time. Okay, so you have this many minutes. Okay, you have this many minutes. Let's see if we are going to add an hour time, what happens. So if we add an hour time, it will be, okay, it's going to be like this. So 24x plus 20y equals to 1.8 million and a 60. Okay, and a 60. It will be is going to be like this. When you solve this, you will get a new x and y. Check. So we substitute here. So what we are doing is we are again recomputing the optimum point. Okay. So when we are recomputing the optimum point, let's see what happens. So x comes to 20,000 2.5 units. Okay, and y is 66,000 units as the same. Okay, now we will find out the new contribution with these units. If we put this in the objective function, the objective function answer will be 20,000 2.5 units into 30 plus 66,000 units into 40. If you put, the answer comes to 3,240,075. So the shadow price will be new contribution minus old contribution. New contribution was this number. We already found that new old contribution. We already found. Where did we find it? See, this is the old contribution. Now you get new units of x. Okay, so 75 is your shadow price. By having 1 hour of extra build time, you will make $75 as contribution. Okay, as contribution. Okay, so that's about the concept here. Okay, that's about the shadow price. Hope you guys got an idea here. So as a, I'll once more I will repeat it. Okay, once more I will repeat it. Slack refers to surplus availability of a constraint. Okay, shadow price refers to the single additional unit of a measure. Okay, of a constraint. If it is available, what would be the contribution? Okay, what would be the contribution? So you can say that, shall I add 18 lakhs rather than putting 60? Shall I put 1 minute? Okay, see, if you put 1 minute, the answer would also will also be there, but the answer would be in very small decimal. Okay, it will be like 1 point for every minute. They will be like earning 1.125 or something. Okay, that will become very small number. So it is better to put something like 60 minutes and check it out. Okay, so that's about this problem. So in this problem, we have seen how to once again. So in this problem, we have seen, we'll see from the top, we have seen how to define the variables, create the objective function, create the constraint, draw the graph, and creating the coordinates, and then drawing the graph. And we also saw solving the ISO contribution line. We saw 2-3 methods we saw. Okay, whichever method you want, you can use it. Okay, the first method is given here. I have done it in this. Okay, the second one, it is below here. Okay, however you can do it in your own way, right? Then we found out the contribution total, profit total, slack we found, and shadow price we have found. Okay, so in an exam you won't find out all these things asked in a question. Okay, what would happen is either they will ask you to create the these constraints alone, or they will give you the constraints and they will ask you to find out the coordinates, or they will ask you to find out what is the optimum profit. Okay, so they will ask you what is slack alone or what is shadow price alone. So they'll ask you in parts only. They will ask, they won't ask you a full length question. So how do you prepare for it? You can't prepare in parts and all. That doesn't work. You have to know how the entire problem is going to work. Okay, then only you can work the parts. Okay, so you can't like learn the parts and do a learn that alone. That doesn't work. You have to learn the entire thing, entire problem you should know. Then only if they ask a question in parts, you will be able to answer it. Okay, so that's about this problem. It is a lengthy problem. So we'll move on to the next one. So we'll start from this problem. So this problem is another linear programming problem, and it was asked in the year December 2010. So it is a bit lengthier problem only here. Okay, so we'll start. The Cosmetic Co. is a company producing a variety of cosmetic creams and lotions. The creams and lotions are sold to a variety of retailers at a price of 23.2 for each jar of face cream and 16.8 for each bottle of body lotion. Each of the products has a variety of ingredients, with the key ones being silk powder, silk amino acids, and aloe vera. 6 months ago, silkworms were attacked by disease, causing a huge reduction in the availability of silk powder, silk amino acids. Okay, the Cosmetic Co. had to dramatically reduce production and make part of its workforce, which it had trained over a number of years, redundant. The company now wants to increase production again by ensuring that it uses the limited ingredients available to maximize profits by selling the optimum mix of creams and lotions. Due to the redundancies made earlier in the year, supply of skilled labor is now limited in the short term to 160 hours or 9,600 minutes per week. Although although unskilled labor is unlimited, the purchasing manager is confident that they can obtain 5,000 grams of silk powder, 1,600 grams of silk amino acids per week. All other ingredients are limited. The following information is available for the two products. Okay, so if you read this question, there are like several things which are so unique. Number one, linear programming can be applied only when there are two products available. Okay, so which ideal combination of the two products have to be produced is where linear programming will help you. So this product has only cream and lotions. Okay, one. Two, this question has a lot of limiting factors. There is actually more than one limiting factor. For example, he says that the maximum availability of silk powder and silk amino acid is limited. Okay, he also tells that skilled labor is also limited. So when there is more than one limiting factor, it is a linear programming. Here we have three limiting factors. Okay, so this is going to be a linear programming question. Apart from that, where they would try to confuse you is in terms of the hours, minutes, and weeks. Okay, so if you see, labor is given in terms of hours and also minutes, and also if you see, it is the numbers which are given are only in terms of per week. Okay, I think the sum would what we would be like ideally finding out is what is the optimum production per week. Okay, I think that's how it should work. Okay, that would be the question, because if they ask you what is the optimum production per month, then we have to like multiply all these numbers by 4. Okay, I don't think that will be the concept here, but be very careful like how he is giving you the numbers in terms of what. Okay, so in terms of this question, he is asking you in terms of week. Okay, and he also tells you all other ingredients are unlimited. The following information is available for the two products. So you have the cream and lotion. So materials required is silk powder at 2.2 per gram. Okay, that's the price of it. See, we don't much bother about the price. Okay, what we are bothered about is a gram availability. Okay, so 3 grams, 2 grams, and see these are also in grams. And the silk powder, here it is. The silk powder is 5,000 grams. So it is going to be like 3x plus 2y equals to maximum of 5,000 grams. Okay, so be careful on this conversion also. This should be in grams and this should also be in grams. Okay, if it's going to be differently given, okay, if it's going to be grams and kilograms, you have to convert and make them equal. Okay, so if it's grams and this is kilograms, means you have to convert this kilograms into grams and do it. Okay, then only you will get the answer. So be very careful in that part also. Apart from that, the second one is silk amino acids at 0.8 dollars per gram. 1 gram and 0.5 grams are required. The availability seems to be 1,600 grams of amino acid, silk amino acid. Okay, aloe vera, again it is 4 grams, 2 grams. So as he has said that all other ingredients are unlimited availability, we don't need, this is not a constraint factor. Okay, aloe vera is not a constraint factor. You don't even need to write it in the equation formation. Okay. And labor skilled, he has said it is maximum available. Maximum is 160 hours available. But if you see here, only like 4 minutes and 5 minutes are given. It's given in terms of minutes. So better, see, rather than converting these into hours, which is like absolutely difficult, okay, better take this 9600 minutes. So it's going to be 4x plus 5y equals to 9600, okay, or maximum availability is 9600. So do what is easier for you. Don't convert this number into hours. Okay, you can put like 4 divided by 60. The number that you will get would be like 0.0 something. So that becomes very difficult for you. So solve the sum in terms of the easiest way. Okay, unskilled labor, you don't need to create any formula or equation you need to find out, because he has said that unskilled labor is unlimited in nature. Okay, so there are only like 3 equations here: silk powder, silk amino, and skilled labor. Okay, so each jar sold generates a contribution of 9 per unit, while each bottle of lotion contributes 8 per unit. So they have given you what is the objective function. The objective function is maximization. Okay, so the maximum demand for lotion is 12,000 bottles per week, and although the demand for cream is unlimited, so you have you have one more constraint. Okay, so this constraint would be like y equals to 2000. Okay, y maximum is 2000 only you can do. Fixed cost is 1800 per week. Why they have given this? Because you have to find out the profit. Okay, the company does not keep inventory, although if a product is partially complete at the end of the 1 week, its production will be completed in the following week. Okay, so all data have been given. Let's see what is the question here. The question is, on the graph paper provided, use linear programming to calculate the optimum number of each product that the Cosmetic Co. should make per week. Assuming that it wishes to maximize contribution, okay, so the objective is maximize contribution. Calculate the total contribution per week, right? So look at here. Now all the numbers are coming into a kind of a construct. So you have to solve the answer for per week. For the new production plan, all workings must be rounded to 2 decimal places. Calculate the shadow price for silk powder and the slack for silk amino acids. All workings must be rounded to 2 decimal places. So you have to find out the shadow price for silk powder and the slack for silk amino acids. Okay, so you can be like sure about one thing here, that is silk powder is a constraint factor. It's a 100% constraint factor, and silk powder lies on the optimal point. Okay, that's like very clear. See, without seeing the answer itself, we can tell what would be the answer. The answer would be silk powder is a binding constraint. Okay, this will be a binding constraint, and there will be no slack, and there will be a shadow price. Okay, and he also says the slack for silk amino acid. That means there will be slack. Okay, if there is going to be slack, this is not a binding factor or a constraint factor, or it is not at all falls on the optimum production point. Okay, so that means silk powder is a falls on the optimum production point, right? See, there are only 3 constraint factors, right? Silk powder, silk amino, and labor. Okay, so silk amino is not a binding factor, or it has a slack, so it is not a binding factor. That means silk powder has a shadow price, it is a binding factor. That means the one more item that is left out is labor. So labor should be a binding factor. So definitely labor line will cross over the silk powder line and will contribute to the binding factor, and the optimum production line will fall on the silk powder, and the labor line only it will fall. See, without seeing the answer, we can deduct a lot of things here. The reason is he has given partially some information to us. We can find it out. Okay, now in exam you can't expect this kind of deductive work and all. You don't need to do in an examination. Okay, but you should know how these things interplay. Without knowing how these things are interplaying, if you write an exam, you cannot write the answer properly at all. Okay, that will become very tough for you. Okay, so we'll start to do this sum. Okay, we'll do this sum in 2 ways. One is using the chart. We'll ISO contribution line we'll find, and we'll find out the optimum point. We'll also use simultaneous method and find out the optimum point. Okay. So in the exam, we don't know which method they will ask, us. So we'll better use both the methods. Okay. So we'll start now. So I already have the chart here. Okay. As I cannot draw a chart in MS Excel, I've got the chart here. So let's start from the doing the problem here. So if you see here, we'll start working out the problem. Okay, the first one is optimum production plan. Okay, we'll start from the optimum production plan. So the first step would be define the variables. Okay, so the variables here are, we have to define X and Y. So X is going to be the cream. The number of jars of face cream to be produced is X, and let Y equal to number of bottles of body lotion to be produced. Okay, so that's about the defining the variables. First, X and Y has to be defined. Okay, or else it's difficult to work out the sum, or else you will actually get confused with the sum. Okay, what is X, what is Y, you will get confused. So be very clear in defining them. Next is, let C be the contribution. Okay, C is equal to contribution. Next one is to state the objective function. So the objective function here is to maximize the contribution. What is the objective function here is C, which is a contribution, is equal to, where do we have C? 9x plus 8y. Okay, this is the 8y. So let's see the number. It is 9x plus 8y. So what you have to do? You have to maximize it. So let's see the next one. Next one is state the constraints. What are the constraints here? There are 3 constraints here. The number 1 is, will be silk powder. Okay, so silk powder, if you see, it is 3x plus 2y. 2y should be less or equal to 5000 grams. Okay, so we got it, 3x plus 2y less or equal to 5000 grams. Next one is silk amino acid, which is 1x plus 0.5y less or equal to 1600 grams. So that also we got it. The next one is going to be labor required. So it is going to be 4x plus 5y, okay, less or equal to 9600 minutes. So we are taking all those 3 in minutes only. So we got that also. We have one more constraint factor, which is the maximum number of units. So lotion is y. So y should be less or equal to 2000. Okay, so here it is. The demand for body lotion should be 2000. Okay, non-negativity condition is these numbers should not be, x and y should not be less than 0. Okay, that also we have written it. So now we'll draw the graph. So to draw the graph, let's see what are the things which are helping us. So to draw the graph, we have to get the coordinate points. Okay, so let's get the coordinate points. Let's substitute x as 0, we'll find a y. So if we substitute here x as 0, okay, then then it is 2y equals to 5000. That means y equals to 2500. So that is one coordinate point. So as you've got one coordinate point, okay, we'll draw it in the graph. Okay, let's put it here. So you can see it here. So x is 0, y is 2500. So where will you put that? X is 0, y is 2500. Here it is. Okay, from here, that's one point. You have to get the other point. Now we'll substitute y as, okay, now we will substitute y as 0. We got this kind of a coordinate, 1667, 0. So 1667 would be lying between these two numbers. So it is here. So you can see here, this one point is here and the other point is here. Draw a line. So 3 plus 2y is silk powder line. Okay. So let's go to the next one. Silk amino acid. Again, x is 0. So y should be 3200. So y is 3200. Okay. One point is here and one more point would be when y is 0, what is x? When y is 0, what is x? X is 1600. So you can put it here. So it is 1600 comma 0. So now connect a line. Okay. So if you connect a line, you connect it from here to here. So it is this line. So this is silk amino acid. Okay, that line. So we got that. So we have to still get for the skilled labor. Skilled labor is this formula. Again, we'll put x as 0. We'll find out y. So the number comes to 1920. And when we substitute y as 0, x comes to 2400. So we'll get the first point. The first point is going to be 0 comma 1920. So 0 comma 1920, it is here. Okay. And the other point was 2400 comma 0. So 2400 comma 0 is here. So we'll draw a line from here to here. Okay, we have drawn a line. So let's see. So maximum demand for body lotion is going to be this line. So this line is a quite simple line where y equals to 2000. That's it. So we have the y line. This is the y line. Okay. So 0 is also here only. So 2000 of y will be from here to here. Okay. It's just a horizontal line. So we've done that. So what we'll do is we'll try to solve this in two ways. Okay. First, we'll try to find out the iso contribution line. So to find out the iso contribution line, we have to take the objective function. We have taken it. We'll randomly assume a number like 10,000. Okay. So see, within, how do you find out like which number you put? Okay. You can very simply, you can take a number like this. Assume that you take a number like 2000 and put it for y. That comes to how much? 16,000. Okay. So something like 16,000. See, we are assuming that only one unit we are producing, the other we are not producing. Okay. So even if you want, you can just take the highest number. The highest number is 3000 or something. Okay, 3000. 3000 of y, if you put, it comes to 24,000. So you can even assume C as 24,000. Okay. Either take any one of the numbers. Okay. So either take the highest number here, 3500 into 8 you put, or you take 2500. That's the highest number here. 2500 into 9 you put. So however you put the total number, I don't think it will cross beyond 25,000. So just take 25,000 as C and work it out. Okay. But what I've assumed is I've assumed it to be 10,000. Okay. Randomly I've taken a number like 10,000. But I'm not taking it randomly. I have taken like multiplication I have done with this number. Okay. I've assumed it to be, it's okay to be 10,000 I've taken. So let's see how it works. So 10,000 C equals to 9x plus 8y. Substitute 0, x as 0. So we got this answer. So we'll find out y. Y is going to be, y is 1250. Okay. So that is one coordinate point. So as we get a coordinate point, we have to draw it also. So we'll put it like this. If you take here, y equals to 1250. So y is 1250. So it is between these lines. Okay, it would be here. The point would be here, one point. Now we'll again substitute y as 0. If we do that, we get the answer to be x equals to 1111. So x1 is going to be 1111. So it will be somewhere here. Okay, so one point is here and the other point is here. Okay, now what we'll do is we'll just put a line. I already have a line. I'll just put a line and show you. 1250, I think it is here, and 1100 should be here, right? 1100 should be here. So I think it would be a little bit here. Now little bit extend this line. by this side and by this side, extend the line, okay, and just see the book answer has given the line to be here, okay. It's like very similar to what the book answer has given. What the line that we have drawn is very similar to what that line is, okay. It doesn't matter where the line is, it can be here or it can be here, okay. It can be in those points, that doesn't matter. What actually matters is whether this line is like similar to this. In angle wise it is similar to this. Now you just have to move this line forward, okay, to find out the optimal point. So let's move it. See the optimal point is within this boundary, okay, within this boundary. How do we know that it is within this boundary? Because if you see all the formulas here, okay, are saying that it's less than, okay. All are, it is a maximization function, and all of them are telling it's going to be left side or below, okay, left side or below. So you can see here this line says left side or below. See, there's no left side in this line, there is only below. So the optimum region is below. All these places are optimal for this line. For all these lines, all these three lines, the below, the left side is the correct one, okay. Left side is this area. This area is impossible to produce, only you can produce within this area. So it's this area or this area or this area, okay. There are three areas. So all the lines, if you see here, you cannot produce more than this line, okay, because your, I think that is going to be labor line. I think this is labor line. Skilled labor will prevent you, this line will prevent you, and you cannot produce even this area. Even though labor is available within this area, you cannot produce because the silk powder, okay, is stopping your production here. You can see here your silk powder is stopping your production at these points, okay. So let's see how to move this line. So we have to move this line whichever is the last point. The last point is, see, we have A point, B, C, D, E. There are 5 intersections. So some intersections we can't even see it visibly, but we don't need to care about that. We just have to move the line. Let's move the line. So you see B is cut, C is gone, remaining is D and C. D is gone, C is the optimum point, okay. C is the optimum point. So the C point is the optimum here, okay. So let's look at what is the optimum units to produced, okay. What is the optimum units which are there? I already have 2 lines drawn. So if C point is the optimum, okay, let's see the production correctly, okay. So see, draw a line from C point to the left side, you get this side, okay. Draw a straight line and draw a vertical line from the C point to the lower one. So you have drawn the line. So roughly this is their optimum units, okay. So optimum units, if you see, it is lying below between 1500 and 1000. So it should be 1200. Roughly it is 1200 or 1250. So if you are going to look at this, you won't get the exact number, but you can get an approximate number. Approximate number is 1200 or 1250 of Y. And if you draw a line from the top to the below like this, you get around, I think that would be 800, okay, 1000 or 800. So 800 of X and 1200 or 1250 of, or 1200 of Y, okay. 800 and 1200. So that is going to be the ideal production, okay. So we'll start with explaining the numbers here. So the optimal point we have to find out. So whatever we have explained through the chart, I will again work it out. So we are going to find out the optimal point, which is a C. Okay. See, without moving the line, you can't find out C. Okay. You have to first of all move the line, then only you will find out C. Optimum units for X after moving the line has been 800. So that's what we have found out here. It was 800 here, and Y was 1250. See, this is like roughly only we can get. We can't get an exact number. If you want to get an exact number, or if the question specifies that you have to do or solve the answer through simultaneous equation, okay, if they ask only, then you have to get simultaneous equation you have to do. So let's see how to do simultaneous equation. So first to find out, see, you have found out the isoquant line, you have moved it, you have found out, see, this is like definitely you have to do. From there on, you have to use simultaneous equation. So what you do is you have found out C is the optimal point. Find out the lines which are crossing on C. Okay, there are two lines which are crossing. One is 3 2 plus 3x plus 2y and 4x plus 5y. Two lines are crossing. That 3x plus 2y line is silk powder line, and the other line is skilled labor line. Okay, we already saw in the question itself that silk powder and skilled labor will be the binding factors. Okay, and now they are the binding factors and they are at the optimal point. Okay, so you have found out it. So now what you will do, you have to solve this and find out X and Y. How do you do that? Okay, how do you do that? So first what we'll do, we'll cancel out the X. To cancel out the X, we will multiply this equation by 3. Okay, and the above equation by 4, so that both equations will become like this. Okay, so 12x is there. So you got, hope you got the idea. So we multiply this by 3, so it becomes 12x plus 15y equals to 28,800. This equation by 4, so it becomes 12x plus 8y equals to 20,000. So both we have multiplied by an appropriate number. See, you have to cancel out x or y. I am trying to cancel out x first. Okay, so how do you cancel out now? Minus the number. Okay, convert this into a minus symbol. Subtract the second equation from 1. If I subtract it, okay, if I subtract it, this is gone. The balance will be 15y minus 8y is 7y. 28,800 minus 20,000 is 8,800. So what is y? This is y. Okay, y. This is the optimum units. Okay, optimum units is 1,257 units. Okay, put this number in any of the equation. In any of these two equation alone, you put it. So I put it in 4x plus 5y. So this is the equation. I substitute 4x plus 5 into 1257.14. We got the answer. The answer, if you solve, comes to 828.58. Solve this on your own. Okay, solve this on your own. You will get 8258, and that is x units. Now look at here. You now got an exact unit. See, approximately we found out through our graph was 800 units for x, but it is exactly 8,028. And approximately we found out it is going to be 1,250, but exactly it is 1,257 units. Okay, so if you want to find out exact answer, simultaneous is required. Okay, approximate answer, just with the chart you can easily find it out. Now you got, either way you got the units. Okay, so we'll use, going forward we'll use these two units. Okay, because it seemed to be exact, so we'll use this itself going forward. So what we have to find now, we have to find out the profit. Okay, to find out profit, we need to find out contribution. So how do we find out contribution? We already know, sorry, so this is the optimum units of x and y. We already know the objective function, which is, okay, which is available here. Our objective function is here, right? So I think it was not there, it is here. Okay, just multiply the units here, you will get the answer. Let's multiply and get the answer. So 8258 of x into $9 contribution is this number. Body lotion, this number of units into $8 contribution is this number. Total contribution is this number. Okay, fixed cost we have in the sum per week, that comes to 1,800, and profit would be 15,714. So we have got our profit. So technically our first part of the question is over. Okay, this is over. Still we have two more things. One is to find out the shadow price and the other one is to find out the slack. So let's find that also. So as he's asking for the shadow price, first we'll find it out. The shadow price for silk powder can be found by solving the two simultaneous equations that intersect at the optimal point C. Okay, so the shadow price is the increase in contribution which would be created by having an additional unit of a limiting factor. Okay, so the limiting factor, there are two limiting factors. One is silk powder and the other one is skilled labor. Okay, we are only going to increase 1 gram. Okay, 1 gram of silk powder to find out what is the shadow price or additional contribution. Okay, so this is the skilled labor. This is the skilled labor formula. Okay, and this is the silk powder formula. Okay, so we are trying to cancel out the x first. Okay, x first. So what we are doing is we are multiplying the first equation by 3 and the second equation by 4. But if you look here, this is skilled labor formula. This is silk powder. Silk powder we are increasing by 1 gram. 5000 grams we are just adding 1 more gram. Okay, this is where shadow price will be differing. For 1 more additional gram, what is your new contribution we are trying to find out. Let's see. So we got the answer for the first one. This is the answer for the second equation. We multiplied. So as usual, we will deduct these. So x will get out, y will become 7y, and this will become equal to, I think some number will be there. Just we'll check. Okay, 8796. So what is y? New y is this number. Because of having additional 1 gram of silk powder. Okay, this is the new y units. Substitute this in, ideally you should substitute this in this formula only. Okay, not in this formula, you have to substitute in this formula. Let's get the answer. So ideally we have substituted there and we have got our new x. Okay, this is our new x now. So if you see, our old y, x and y will be different from this. Check it. Earlier x was 828, now it is 829. 1 unit has increased. Earlier y was 1257, now it is 1256. Okay, this has gone down. Okay, you don't need to worry about that and all. Okay, because overall this will increase your contribution. Let's see how and this increases the contribution. So let's get the new contribution here. So new contribution is going to be, so face cream is 825. Okay, 828.58. I think that is, the old contribution. So let's get that. That's the old total contribution. So we have already got that. Okay, let's get the new one. Okay, I think it's here. Okay, so let's substitute this in the and find the shadow price. Okay, new contribution minus old contribution we have to get. So the new contribution is going to be 9x. Okay, so x is 829 units and y is 8 into 1256. So this is the new contribution. Let's get the new contribution. New contribution is 17,516. Let's get the old contribution. The old contribution is this number. So shadow price for silk powder is, for per gram of silk powder you add, you will get 1.83 as the contribution. Okay, so per gram you will get. The additional contribution that can be earned for 1 additional gram of silk powder is 1.83. Okay, let's find out the slack for amino acid. Okay, amino acid will have a slack because it is not in the optimal point. Okay, the line is not crossing the optimal point. So let's get that. So how do you get that? It's very simple. First get the amino acid formula or equation for that. It was here. Okay, 1x plus 0.5 y less than 1600. So okay, so this is the total grams required, right? See, this should be the original numbers. Okay, this should not be the revised numbers. Revised numbers we have it here. This is a shadow price calculation we did. That we should not take. We should take the original thing that we calculated. The original thing that we calculated was here. Okay, so for that only you have to work out. Okay, so we'll work it out. So 828.8 into 1 and 0.5 into this unit. So totally we require 1457 grams, but grams available is 1600. So of course you are going to have a surplus. Surplus is called as slack. So you have 142 grams as surplus. Okay, so that's about this sum. Okay, hope you got a good idea about this sum here. This has been a lengthy kind of a sum here. This has been a lengthy kind of a sum. Okay, hope you get the idea. So I'll just summarize it once. First, define the variables, find out the objective function, then find out the constraints. Okay, form the equation, then find out the coordinate points that you have to draw in the graph. Of course, you have to draw the graph. Then solve the graph points. Okay, and create a graph. Then you have to draw a line of iso contribution curve. That line, if you want to draw, you have to assume the contribution as some number. The best way is to find out, take x number is 9x. See the maximum that is available. Maximum available is 2500. So 2500 into 9 is 22,500. Take c as 22,500. Okay, I have taken 10,000. Okay, randomly I have chosen this number, but you do as per this procedure. Then substitute x, and finally you have found the optimum contribution line. You have found, once you have found the optimum contribution line, move the line towards C. So move the line outside and you will get the optimum point. When you move, C is the last point to touch, so it becomes the optimum point. Roughly it is 800 units of x, which is this point, and y, and 1250 units of y, which is this point. Okay, so if the question asks you to find out the exact numbers, or it asks you to find out solve the sum through simultaneous equation, then what you should do is you have to find out what are the lines which are crossing the optimal point. So the optimal lines which are crossing the optimal point are silk powder and skilled labor. Solve them, find out x and y. Okay, so exact number of x and y you can find it out. Then find out, multiply it by the contribution per unit, you get the total contribution. Fixed cost you minus, you get the profit. To find out the shadow price, it's very simple. Take again the two line equation which are crossing the optimal point, the silk powder and the unskilled labor. For you can find out the shadow price for both silk powder and skilled labor, you can find out. But whichever the question states to find out the shadow price, here they ask you to find out the shadow price for silk powder. So in silk powder equation alone, you increase it by 1 gram. Okay, if they ask you to find out the shadow price for skilled labor, okay, then you increase 9600 and 1. Okay, the other one would be like just 5000. Okay, just increase the one for which you are trying to find out the shadow price. Then solve them, again find out x and y. Now again substitute it in the contribution and find out the new contribution. Your contribution will increase. Okay, it has to increase. Your new contribution will be higher than the old contribution. If it is not, then you have done the sum wrongly. How to interpret the answer? if the shadow price for silk powder comes to 1.83, it is per gram only. Okay, for per gram you are making that profit. Okay, per gram it is a profit. Okay, so the that's how the shadow price works. Slack would be whether it is available or not. Okay, so we for slack we just apply the originally found units, optimum units. So availability is requirement is this, availability is this. For slack it will usually be surplus availability, so it will never be on the optimum line. Okay, so hope you guys got a good understanding about linear programming. It is a lengthy problem. Okay, so you should have a very good idea about this, because the questions can be asked in any kind of manner. Okay, so thank you guys, we'll meet in the next video.